Now the last group that we need to name are the acids, and I find that they happen to be the hardest to name, at least in my opinion, hardest to remember how. They are compounds that form H plus in water. That's by definition what an acid is, and we'll spend a whole entire 3 weeks towards the end of the school year dealing with the chemistry of acids, but we need to talk about how to name them here while we're talking about the other compounds. So therefore, the formula usually begins with a hydrogen. In order to be an acid instead of just a regular gas, the acid must be in water. So HCl, hydrogen chloride, is a gas. When that hydrogen chloride is put in water, it then becomes an acid. So you can actually name these compounds as acids. You can also name them as binary molecular compounds. So HCl, for example, hydrochloric acid. HNO3 is another fairly common acid, nitric acid. And then finally, the last example I have here is H2SO4, which is sulfuric acid. We need to go through the naming of these and then how to write their formulas. So let's take a look at the nomenclature. If there is no oxygen in the acid formula at all, it's very simple. It's just hydro, and then the stem name is the main element other than hydrogen. Stick ic on the end, and then the word acid. If the acid contains oxygen, you must figure out whether it has a polyatomic ion in it that ends in ATE or one that ends in ITE. If the polyatomic ion ends in ATE, you're going to take the stem, that is the main element in the polyatomic ion, stick ic on it, and then the word acid. If the polyatomic ion ends in ITE, you're going to take the stem, the main element in the polyatomic ion, stick OUS on it, and then the word acid. And there's a kind of easy way to remember. In the cafeteria, you ate something icky, so ate goes with ic. Ate goes with ic. And then notice when you have oxygen in an acid that you do not begin the name with that hydro prefix. So, again, here's the flow chart. Acids start with H. If there's two elements, it's hydro, and then prefix, and then ic ending. If it's three elements, no hydro, but you need the prefix, and then the ate of the polyatomic ion becomes ic, and the ite becomes us. And the best way probably to go about doing this is to actually try some. So let's take this first one, HBr. Notice all three of these formulas start with hydrogen, so we know that they're all acids. The first one, HBr, has no oxygen. So if you look back at the previous notes that you've taken, if there's no oxygen in there, you simply write hydro, the name of the main element, which is bromine, but we want it to end in ic, so therefore it's going to be hydrobromic, and then we want to put the word acid there. So that becomes hydrobromic acid. Now the second one, H2CO3, there's an oxygen in there, so that means you need to look at your polyatomic ion chart, find CO3. CO3 is actually carbonate. Carbonate ends in ATE. ATE. So remember our nomenclature. In the cafeteria, you ate something icky. So if it's ate, our acid ends in ic. So this is going to be carbonate, but we want the ATE to be ic. So it becomes carbonic acid. So we simply take the polyatomic ion, chop off the ATE, and stick IC there. Now the last one, H2SO3, again it has oxygen, so that means it has a polyatomic ion. We looked that polyatomic ion up, and its SO3 is actually sulfite. Sulfite. So it ends in ITE. So therefore we want the acid to end in OUS. Now this one's a little funky. Instead of calling it sulfus acid, they include the whole sulfur and then OUS acid. So that's something you're going to have to get used to, trying to kind of figure out which syllables to keep in there and which to not put in there. And we'll help you along with this as you name these acids in class. Now, let's take these three and actually try to write the formula for them. So let's start with hydrofluoric acid. There's two elements in it. We know that because it starts with hydro. And the two elements are simply hydrogen and the other element in the name, which would be fluorine. Hydrogen has a +1 charge. Fluorine has a -1 charge. So the charge is balanced. So we get HF as our formula for hydrofluoric. So notice I did use charges here. You need to use charges with the acids when you write the formulas. The second one there is sulfuric acid. Now there's no hydro, so that means there's an oxygen in this acid formula. So we go to the polyatomic ion chart. We look for a polyatomic ion that has sulfur in it. Because this is ick, remember I ate something icky, because this has ick, we're looking for a polyatomic ion with sulfur ending in ATE. When we look that up, we actually get SO4. It has a -2 charge. Hydrogen has a +1. Keep in mind we're always trying to balance charges. So that means to balance the -2 charge on the SO4, we're going to need 2 of those +1 hydrogens. So just like we did with all the other ionic compounds, we want to treat these acids as if they're ionic. We end up with a subscript on the hydrogen. We end up with H2SO4. Now, the last one, nitrous acid. So it has no hydro at the beginning of the name, so that means it's 3 elements. So that means that has a polyatomic ion in it. It's OUS ending. OUS goes with ite. So on the polyatomic ion sheet, we're looking for a nitrogen-containing polyatomic ion that ends in ITE. And in fact, there is a polyatomic ion like that. It's NO2 with a -1 charge. And remember, you'll have those polyatomic ion sheets in front of you for reference. So the hydrogen is +1, the NO2 is -1, the charge is balanced completely, so we end up with a formula of HNO2. Now, how about if you try 5 of them, and we're going to start with the naming. Okay, so have the acid flow chart in front of you, and you want to name the 5. So you may want to pause this here and attempt to name the 5 of them. Then we want to go backwards. So I'd like you to write the formulas for these 5. So again, you may want to pause here, have the acid flow chart in front of you, and give a formula for each of the 5 acid names that you see here on the slide. Now this chart overall sums up everything. So this has all of the naming. This is something I would definitely put into the notes. This is going to allow you to name any compound. So you ask yourself the question first, is there an H in there? Does the compound start with an H? And that will send you either to the left part of the table of this flowchart or the right part. If there is an H, is it a binary compound? So if it's a binary compound, you go to the left there and you're basically naming the binary compounds. Is there a metal present? Do you need Roman numerals in there? If you go to the right there, if there is a hydrogen present, is it a binary compound? Does it contain oxygen? So basically what it boils down to is the whole right side of this flowchart is naming acids. The whole left part of this is naming ionic compounds, and then also naming molecular covalently bonded compounds. Okay, so you want to start at the top of this flowchart and work your way down with any of the formulas that you see. You should be able to name them. So this definitely needs to be put into your notes. That should summarize everything.